Okay, final section of chapter 9. We're going to be solving systems of inequalities, and inequalities are the ones, remember, where you've got either a dashed line or a solid line, and then you figure out where you're supposed to be shading them. So we are going to figure out exactly how to do these. They're all going to be some sort of combination of, we've got lines, absolute values, those are from the past, and then we have circles, ellipses, hyperbolas, and parabolas. So with part A, this first one right here, we've got a parabola because you just have a y and that's an x squared. And then this is a circle. All right, so the way we do this is we figure out exactly how each one of these is going to be shaded kind of in and of itself, and then we'll look for the combination with the overlap of the shading. All right, so if we go to set this up, we're going to make just some notes about each one by itself. So this one is a parabola. It's in vertex form. So for graph 1, we know it's a parabola. And then its vertex, there's nothing in there with the x squared, so it must just be at 0 and then at 1. And then we can plot 2 points. We've got, from 1, 1 and negative 1, 1, we can make some transformations. So since there's nothing in there with the x, there is no transforming happening with the x value at all. There's nothing in front of the x squared, so there's no multiplying. All this does is just adds 1 to the x values. So this becomes 2, this becomes 2. So we've got those 3 points that we can plot for our parabola, and then a couple more notes to make when we start to plot. We've got 0, 1 would be right there, 1, 2 would be right there, and negative 1, 2 is right there. So before you go to plot it, make sure you're paying attention to the inequality. So this is just a greater than, so this one would be dashed. Okay, definitely going to be a dashed line. So let's start with that. All right, so we got our dashed parabola, and then when we do some sort of test value, so let's test 0, 0, easy enough. As long as 0, 0 isn't on the graph, you can test it. So if we test, is 0 greater than 0 squared plus 1? Is 0 greater than 1? No, it is not. That's false. So that means that 0, 0 is not part of our shaded region. All right, so since 0, 0 is not part of the shaded region, we are going to shade up above it. All right, so everything kind of inside of this dotted parabola is going to be shaded. So now let's look at the next one. Next one is a circle. We know that because it has x squared plus y squared, and because the coefficients in front of them are the same. So it's definitely going to be a circle. So for circle, we need the center and the radius. Our center, notice there's nothing. It's just a plain old x squared and a plain old y squared. So that would be 0, 0 for our center. And then our radius, this is our squared. So you take the square root of that and you get 3. So our radius is 3. When we go to graph this, remember we don't actually graph the circle, we just mark it. I'm sorry, the center. We mark the center. And then our radius of 3 means we're going 3 units in every direction and leaving a point there. Okay, now take a look at this because it has the or equal to, that means it's going to be a solid line. So we just fill in the dots around this circle, graph it in. So now with the parabola, you could either be kind of inside or outside the parabola, or kind of above and below sort of. With the circle, it's either you're inside the circle or it's everything outside of the circle. So let's test. 0, 0 is not right on the circle. It doesn't matter that it's the center. What matters is whether it's on the circle or not, and it's not. So we can test, is 0 squared plus 0 squared less than or equal to 9? And 0 is definitely less than 9, so that's true. So that means that 0, 0 is part of the shaded region for this circle. All right, so that means that I can shade everything like that. Okay, so we've got shaded parabola, shaded circle. Remember, your final answer is where they overlap. So, I've got my colored pencils out and ready. We got red, yellow. This we're going to make a dark orange right here. So that is the part where they overlap. So make sure, whether it's with color or just a darker pencil or darker pen, make sure you are in some way recognizing the part that is the solution, because this is the solution to this system. It's the part that makes this one true and makes this one true, would be the overlap between those shaded regions. All right, so we got that first one. Let's look at the same thing with our second one. This one is a hyperbola because it is an x squared minus y squared. So let's set that one up. So graph 1 is a hyperbola. It is centered right at the origin here, 0, 0. And we should technically be dividing everything by 8 to get it like really in its standard form. So that should be minus y squared over 8 is less than or equal to 1. Okay, so to get it in the form we're used to, we divided everything by 8. Sorry about that little smudge there. I started to write plus, should be minus. So our conjugate axis and our transverse axis, we're going root 8 in both directions. So to go to our vertices, we are going to go root 8s left and right. And to get to our co-vertices, we are going to go root 8s both up and down. Okay, so we can start to plot that one. So our hyperbola is centered right at the origin. Remember, we just kind of mark the center. And then we're going to go root 8 in all directions, which is just going to be a little bit smaller than 3. So we're going to go 2, 3, so you know, somewhere like there, just estimate. So we're just estimating. That's going to be the sides of our hyperbola like that. And then if we go up just a little bit less than 3, just kind of mark there. That's just going to help us draw our box so we can get those asymptotes in there. All right, so I'm going to use my pink pen again. So we make this little box, and then we draw in our diagonal asymptotes, helping us guide exactly where our hyperbola is going to go. So through the corners of that box, through the center. All right, so now let's go to shade it. So this is a less than or equal to, so you know that's going to be solid. So we're going to come right along these lines through the point and out the other side. It's going to be solid because my line does have the or equal to. Okay, so the hyperbola itself will look like this. Now we got to do a true-false check. Okay, so do a test. 0, 0 is the center, but it is not actually on the line of the hyperbola, so it's perfectly fine to check. So 0 squared minus 0 squared, is it less than or equal to 8? Yes, 0 is in fact less than 8, so that's true. So that means this is part of the shaded region. With a hyperbola, it's kind of interesting. You either do everything in the middle like this or everything in the wings like that. So we are going everything in the center like that because 0, 0 came out true. Okay, so that's our first shaded region. It's just that. So now let's check the other ones. This is x squared plus y squared greater than or equal to 120. This is a circle. We have an x squared plus y squared, and they have the same coefficient. So this is another circle. So our center is just right at the origin, just 0, 0, because that's just an x, that's just a y. And our radius is the square root of 120, whatever that is. Now notice it's going to be just a little bit less than 11. Okay, so root 121 would be 11, so it's going to be just a little bit less than 11. Really should have scaled this. That's okay. All right, so 4, 5, 6, 7, 8, 9, 10, 11. 5, 6, 9, 10, 11. All right, we're going to take it pretty much the whole page here. All right, so really, really big circle. This is a greater than or equal to, so it is solid. Oh, this is going to be my worst ever. Oh my God. Okay, there you go. There's a circle, sort of. Let's check this. Greater than or equal to 120. So when we do a test, 0, 0 is the center, but it's not part of our circle, so 0, 0 is fine. 0 squared plus 0 squared is greater than or equal to 120. That is definitely false. That means 0, 0 is not shaded. So the part that we do shade is the outside of the circle. Okay, so everything outside of this circle is what gets shaded. All right, so the important part is to look for the overlap. So I didn't quite shade as much blue as I realized I needed to. It's all up there, all down here. So what the overlap is going to be is this very strange region that, and I'm going to keep my hyperbola going so you can see. This region that's kind of on the inside of the parabola, but on the outside of the circle. So shade this darker, it ends up being this whole region out here. It's inside of the hyperbola, but outside of the circle. So you've got this part of region, and it would extend farther and farther up that way. And then same thing down here. We're outside of the circle, yet inside of the parabola. And again, that would just continue to extend downward. So that is your overlapping region for that one. We got one more of these. Okay, so that first one, again, is going to be a circle. We have x squared plus y squared with the same coefficient. So graph number 1 is going to be a circle. The center is, again, at 0, 0, because there's nothing in parentheses with the x or the y. And then the radius is 4, because that's r squared, that's 16. So I take the square root of that. So let's graph. Okay, so my center, again, right at the origin. Don't plot a point, just mark it. And since my radius is 4, I'm going 4 units in all directions, leaving a point there. Can only get better than that last circle. Okay, so we got those points. This is just a greater than, so this is going to be a dashed line. Okay, so it looks like that. And then when I do my test, I'm going to test out 0, 0, see what comes out. So is 0 squared plus 0 squared greater than 16? Well, 0 is not greater than 16, so that's false. So we're doing basically the same thing we did in that one up above. We're going to be shading outside the circle. So anything outside, so 0, 0 is not part of our shaded region. So we start with this whole region outside the circle is our first shaded part, and then we'll see what the next one gives us so we can figure out what the overlap is. All right, so we got that so far. This is an absolute value graph. Okay, so remember your absolute value normally just starts off like right at the origin with that V shape. So now there's just one quick little transformation. Remember when you see +4 inside of a graph, it means it's shifting it to the left 4 units. Okay, so this second one, that is an absolute value. And what we're going to do is basically just graph that normal absolute value, but it's going to shift 4 units to the left. All right, so it's going to start at -4, 0, and then just go up from there. Okay, so it's going to start right here, and then it's going to be an absolute value graph. It's going to be dashed. Always pay attention to that detail because this does not have the or equal to. So you just have this V shape going up from there. So that is your absolute value, just like that. And we're going to test one last time, one last graph. Test 0, 0. We want to know, is 0 greater than absolute value of 0 plus 4? Okay, so this is 0. Is 0 greater than 4? No, it's not. Okay, so that means 0, 0 is not part of the shaded region. So with absolute value, it's either kind of outside the graph or within the graph like that. So what we end up shading is the part that's within the graph because 0, 0 came out false. So I shade the opposite region of where the 0, 0 is. So I shade all this. All right, so what we end up getting is the portion that is inside of this absolute value graph and also outside of the circle. So anything, it really just kind of discludes this portion right here because I got to make sure that I'm outside of the circle. So I'm everything inside of this absolute value graph, but just make sure you're not touching like this little part right there that's inside the circle. So it would keep going, of course. It would kind of fall inside this entire absolute value graph. I didn't run into this giant circle that I made. Just make sure that this part is not included right here because it has to be outside of the circle, yet still inside of that absolute value graph. All right, so that is it for Chapter 9.